Welcome to AP Economics. Thank you so much for joining me tonight. Tonight's topic is money growth and inflation. And as you know, we're working on Unit 5 this week and into next week to help you prepare for the AP Macroeconomics exam. We hope that you've enjoyed our lesson so far and that these are helpful to you as you work through whatever your circumstances are. For those of you who are signing in now and watching on your own time, thank you so much for continuing to care about your education. My name is Jen Rayfields. I teach at Ridge High School in Basking Ridge, New Jersey, and I'm thrilled to be doing this and helping you with your economics education. All right, so I'm going to take you through what we're going to do tonight. So our topic is 5.3, which is money growth and inflation. And the content objective, the primary one, is we want to be able to explain using graphs how inflation is a monetary phenomenon. And so that's a mouthful. We're going to unpack it over the course of the lesson. We're also going to get into the quantity theory of money. And we're going to be able to calculate the money supply, velocity of money, the price level, and real output using that quantity theory of money and its associated equation. There's also a skill objective we're going to be working on tonight, and this is a really important one. So skill 3A asks students to be able to determine the outcome of an economic situation using economic concepts, principles, or models. So really what that means is you're going to be given a cause and you have to figure out what the outcome is. What is the effect of the cause that you're giving, which is like the opposite of skill 2. Skill 2 is you're giving an outcome and you have to determine what the cause or likely cause of that outcome was. So that's the skill we're going to be working on. And so you'll know if you're ready for this topic and this skill on the AP Macro exam when you can do these two things. You want to be able to explain and predict how monetary policy applied to an economy in long-run equilibrium will affect output, unemployment, and the price level. The second thing you want to be able to do is use MVPQ, which is the monetary equation of exchange, to predict how changes in one variable in that equation will affect the others. So that's what we're going to be doing tonight. But before we get in, I think Mr. Romano assigned you some homework, and I'm going to pull up the question that finished off your lesson yesterday. So what I've done is I've broken it up into its two parts, and I'm going to give you some time, if you didn't already do so, to see if you can review what you learned about the Phillips curve. So let's go to part A. So I'm going to give you about a minute. I want you to read the question, pay careful attention to the directions, and then take about 60 seconds or so to sketch out this graph. Okay? Go ahead and get started. As you're graphing, don't forget, you always want to make sure that you're clearly and accurately labeling your axes. You also want to make sure you include the necessary curves for the model that's called for. In this case, you're told we need a short run and a long run Phillips curve. So put your curves in there and label them. You're also given a short run equilibrium point, and you should use the numbers in the problem to find that point in the model. So take another 10 seconds. Okay, let's take a look and see how you did. All right, so when you're putting together your Phillips curve model, you want to remember that you are looking at two curves that describe the relationship between the inflation rate and the unemployment rate. Okay, that's what your axes labels are. We have a long run Phillips curve that's vertical because it illustrates there's no trade-off between inflation and unemployment in the long run. The long run Phillips curve is vertical at the natural rate of unemployment, which we're told in this case is 5%. So we're going to label our long run Phillips curve with 5% inflation. The next part of the problem asks us to have a short run Phillips curve and a short run equilibrium point B. So where do we put that point B? Well, we're told the country has an actual unemployment rate of 7%. So use what you know about axes. So if this is 5%, 7% has to be greater. So make sure your 7% is over here. So once we find 7% unemployment, we can trace it up to the Phillips curve, lay in our corresponding 3% inflation, and then label it point B. So that's what you should have done to earn the points for this part of the problem. So now we're going to go to part B and we're going to do something similar. I'm going to bring the graph with us though, just so that we have it in front of us while we're looking at the problem. So this is part B. Assume the government of country X takes no policy action to reduce unemployment. In the long run, will each of the following shift to the right, shift to the left, or remain the same? So we have to answer the question about the short run aggregate supply curve and eventually the long run Phillips curve. But take about 30 seconds to think through what you know about the relationship between the Phillips curve model and the ADAS model, which is where the short run aggregate supply curve is. And then we'll go through the reasoning. I'm going to give you a hint. Given what you know about the difference between the natural rate of unemployment and the actual rate of unemployment, that might help you think about what's going on in the ADAS model. Okay, take another 10 seconds. Okay, so the answer is the short run aggregate supply curve is going to shift to the right. Let's work through the reasoning for that. So when the actual unemployment rate is greater than the natural unemployment rate, we know the economy is experiencing a recessionary gap. In a recessionary gap, what we're looking at is unemployed or underemployed resources. The most important resource in the US economy is labor. So you've got a lot of workers who are looking for work. You've got producers of natural resources who aren't selling all of their products. You've got capital stock that's not being used to produce goods and services. So when the economy is in a recessionary gap, all input prices are underemployed, and that's going to lead to a decrease in the price of them. So in a recessionary gap, wages and other input prices are going to fall, and that leads short run aggregate supply to increase. When short run aggregate supply increases, we represent that in the ADAS model by shifting the short run aggregate supply curve to the right. All right, let's work through part B, B2. Okay, what's going to happen with our long run Phillips curve as the economy returns to long run equilibrium? Okay, we've got three choices: shift to the right, shift to the left, or remain the same. Those are not bad odds if you have to take a guess at it, but it's probably better to make sure you understand what the shift factors of the Phillips curve are. Okay, so remember that the long run Phillips curve is a function of the natural rate of unemployment. What it really tells us is that the economy can adjust to long run equilibrium at the natural rate of unemployment or at full employment levels of output at any inflation rate. Okay. Natural rate of unemployment equals frictional unemployment and structural unemployment. Those are the kinds of unemployment that you want in an economy. It shows that there's a dynamic economy. People are entering and exiting the labor force. As some people's skills become obsolete, it results when innovation requires and leads to the need for new skills, right? A dynamic economy is always going to have some frictional and structural unemployment. The natural rate of unemployment is not affected by the business cycle, though, right? So the long run Phillips curve, which is a function only of natural unemployment, is not going to be affected by changes in the actual unemployment rate. So we are going to take a look now at what a full point answer to this question would look like. So you'd have your graph for part A, and then you'd have your answer to B1 and your answer to B2. Remember that how important that explain word is. When you have an explain point, you want to assert the answer to the question and explain why your answer is true. Our assertion is the short run aggregate supply curve will shift to the right because input prices fall due to the recessionary gap where resources are underemployed. And the long run Phillips curve will remain the same. Okay, which is a really nice lead in to a little bit more review that we want to do to get to our topic. It's one of the great things about Unit 5 is that it gives us a chance to reinforce a lot of what we've learned in previous units and then extend them. So that's what we're doing now. You already know the mechanisms of monetary policy. You already know what inflation is. Now we're going to extend these two ideas. So before we do that, we just want to remember a few key things about this Phillips curve, right? The short run Phillips curve shows the trade-off between unemployment and inflation in the short run. Changes in aggregate demand result in a movement along a given short-run Phillips curve. Changes in short-run aggregate supply and changes in inflationary expectations are going to shift the short-run Phillips curve. The long-run Phillips curve is vertical at the natural rate of unemployment. Some of you might have textbooks that describe it as the NIRU, or non-accelerating inflation rate of unemployment. Either one is correct. They mean the same thing. There's no trade-off between unemployment and inflation in the long run, and changes in the natural rate of unemployment are going to be those things that shift the long-run Phillips curve. For example, if there is a major increase in the number of high school graduates who seek to go to post-secondary schools, trade school, college before entering the labor market, that's going to change the amount of frictional unemployment in the economy, and that would shift the long-run Phillips curve. Cyclical unemployment, again, is not a shift factor of the long-run Phillips curve. Okay, so let's quickly review inflation, right? We know it's defined as a sustained increase in the overall price level, right? Not an increase in the cost of a few goods and services, but a sustained increase in overall prices. Indicators of inflation include GDP deflator, the consumer price index, and the producer price index. When we label the ADAS model with the aggregate price level here on the vertical axis, we could substitute that very easily with the GDP deflator or the CPI. Remember, the CPI and the GDP deflator are expressed as some number out of some number. And then when we compare the CPI in one year with the CPI in another year, that's how we measure inflation. So let's assume we've got the GDP deflator as our vertical axis and that the current GDP deflator is 100. We have an economy in long run equilibrium. So now there's two types of inflation that you learned about. Demand pull inflation, which results from an increase in aggregate demand. When you graph an increase in aggregate demand, you shift the aggregate demand curve to the right. Now, one of the things that I want you to remember, when aggregate demand increases, all else equal, what it means is at the current price level, the quantity of aggregate output demanded is greater than the quantity of aggregate output supplied. That creates a shortage. So how are shortages eliminated? Through rising prices. So as the price level rises, right, we're going to see an increase. We're going to see inflation. So when the price level rises from 100 to 110, that's an inflation rate of 10%. The other kind of inflation you learned about is cost push inflation, and that results when there's a decrease in short run aggregate supply. So a decrease in short run aggregate supply creates, again, a difference between the quantity of aggregate output demanded and the quantity of aggregate output supplied. And that's eliminated by rising prices again. So in this case, if the price level were to go from 100 to 115, that would represent a 15% rate of inflation. So that's what inflation looks like in the model. You've also learned about monetary policy in the short run, and you've learned about how it is applied to short run output gaps. So we've learned that expansionary monetary policy that's applied to a short-run recessionary gap can stimulate spending and borrowing, which increases aggregate demand and real GDP. Remember that monetary policy influences spending through the interest rate. So it's really that spending that people do with borrowed money that causes aggregate demand to change as a result of changes in the interest rate. So when expansionary monetary policy is applied to a recessionary gap, that's what we're showing here. We're showing current output here at equilibrium in a recessionary gap below full employment levels of output. We'd use expansionary monetary policy to shift aggregate demand to the right. Well, notice that when that aggregate demand curve shifts to the right, we're returning the economy to full employment levels of output, but there's our Phillips curve trade-off. Increasing output reduces unemployment, but it comes at the cost of higher prices, right? It comes with some inflation. We've also learned that contractionary monetary policy, when applied to a short-run inflationary gap, can stifle spending, which leads to a decrease in aggregate demand and real GDP. So if we were going to use monetary policy to try to close this inflationary gap, we would do so by lowering the money supply, which drives up interest rates, which leads to less interest rate sensitive spending on consumer goods and less investment spending. Aggregate demand decreases, and we close our output gap. As the price level comes down, however, the amount of output we're producing also decreases. And when that happens, employment falls and unemployment rises. Okay, so we've learned about monetary policy in the short run. So now we're ready to get into what you need to know about topic 5.3. And what we're really looking at in this whole unit are the implications in the long run of fiscal and monetary policy. So we're starting here with monetary policy in the long run. So the question we want to be able to answer is, what are the long run implications of monetary policy for the macroeconomy? So we're starting here with an economy in long run equilibrium at full employment levels of output, where short run aggregate supply, aggregate demand, and long run aggregate supply all intersect. Let's say that the Fed or a nation's central bank decided to try to stimulate economic growth, decided to try to produce output beyond full employment levels of output. They could implement some expansionary monetary policy. We know the mechanisms of expansionary monetary policy, and we know how that affects aggregate demand. So you can anticipate where the aggregate demand curve is going, right? When aggregate demand increases, we see an increase in the level of output, which is corresponds with a decrease in the unemployment rate, and we see an increase in the price level. So we arrive at a short run equilibrium here at E1. So the question then is, will the economy stay there? Can we sustain a level of output beyond full employment levels of output? Imagine that the natural rate of unemployment is 5%, which is about what it is in the United States. The natural rate of unemployment is about 5%, and we're producing more output. We need more workers. That means the actual unemployment rate is below 5%. So when you get into 4%, 3%, 2% unemployment, you're pulling frictionally unemployed workers in to do jobs that they might not be completely well suited for. You're taking structurally unemployed people whose skills might not be well suited for the work that you want them to do, but you're desperate to hire more workers in order to satisfy the increase in demand. So what's going to happen? Right? Workers are going to be in short supply. Workers are going to recognize that there's a high demand for labor, and they're going to begin to demand more wages. The minute input prices begin to rise, all else equal, profitability for producers is going to go down. When there's a decrease in profitability, short run aggregate supply shifts to the left. So the economy cannot sustain itself in an inflationary gap in the absence of any involvement, any economic policy. The economy will return to equilibrium at long run at full employment levels of output. So the initial increase in output came with higher price levels. Workers bid up wages. The increase in input costs leads to a decrease in the short run aggregate supply curve, and we return to full employment levels of output. But look over here what happened to the price level. The initial monetary policy produced inflation, and the subsequent self-correction produced more inflation. So what does that tell us about the long run outcomes of monetary policy? Well, in the long run, real GDP is not going to change. And as a result, employment is not going to change, but we do see increases in the price level. Okay, and this should lead you to some important understandings. The productive capacity of an economy is captured by the long run aggregate supply curve. Okay, and that's a function of the amount of resources in the economy. And as you learned way back in Unit 1, the factors of production, the resources we use to produce goods and services, land, labor, capital, entrepreneurship, that's what determines the full employment level of output that we can produce, right? The long run aggregate supply and YF represent a level of output on the economy's production possibilities curve, right? Some combination of consumer goods and capital goods. So this leads us to the conclusion that the real economy, right, which is a function of the productive capacity of its resources, is independent of the money supply. It doesn't matter how much money is in the economy when it comes to how many goods and services we produce. As a medium of exchange, money does a terrific job facilitating economic transactions, but it's not a factor of production and it's not a resource. And what the conclusion we draw is that in the long run, money is neutral. In other words, in the real economy, the amount of output we can produce is independent of the money supply. Okay, so we've been able to illustrate that graphically. We can describe it conceptually. So what I hope is that this makes a lot of sense to you, but it would be a really good idea if you're watching this afterwards to see, can you explain this in your own words? or if you're watching this later on, pause the video, because one of my great colleagues always says economics is seductively intuitive. As I remember being a student in my college economics classes, listening to my professor, anticipating, oh yeah, the curve's going to shift to the right. And then the curve shifted to the right. And I was so excited. I was like, I love economics. And then I would try to do it myself. And I'd be like, which way does the curve shift? Why does it shift that way? So try to make sure you can put this in your own words. This is the key concept of this unit right here. Okay, now we can express it another way too. And so now we're coming to the quantity theory of money, which asserts that the amount of money that is exchanged in an economy is equal to the value of the goods and services that are sold in the economy. Okay, so it's expressed using a formula that we call the monetary equation of exchange, which is written as follows: MV equals PQ. So you'll see this a lot, you'll hear this a lot. MV equals PQ. This equation captures this concept. In some textbooks, it's written as MV equals PY. So let's break this down. What do those variables represent? Well, in this monetary equation of exchange, M stands for the money supply. V stands for something called the velocity of money. And what that refers to is the number of times a given dollar bill is used to facilitate an economic transaction in a given year. How many times does the same piece of currency change hands, right? You don't need the same number of dollars in the economy as your GDP, as your nominal GDP, because each dollar gets used again and again and again. We also know that the economic data shows us that the velocity of money tends to be fairly stable over time. So in this equation, M stands for the money supply, V stands for the velocity of money, P stands for the price level, Q stands for the quantity of output. And as you know, right, Y in the ADAS model stands for real GDP. So whether you're reading MV equals PQ or MV equals PY, what you're reading is that the money supply times the velocity of money is equal to nominal GDP, right? Because P times Q, the price level times the quantity of output, is what is meant by nominal GDP. So MV equals PQ can be expressed as MV equals nominal GDP. And this is something you really want to make sure you understand. When you see MVPQ in your mind, immediately think, oh, MV equals nominal GDP. P times Q is nominal GDP. Okay, so now that we've broken down the formula and its component parts, let's take a look at how we use it. Okay, this will further our understanding of the long run neutrality of money. It's going to further our understanding of why we don't use monetary policy to try to achieve economic growth. It can help us in a short run output gap, but many economists, many people believe that money is neutral in the long run. So let's think back to, like, why do we use economic policy in the first place, right? What are the goals of macroeconomic policy? Well, we know the Fed has a dual mandate in the United States. Most central banks are concerned with price stability in the United States. Our dual mandate for the Fed requires it to set goals, including sustainable increases in output to provide employment. So we want to keep workers working, but we also want to keep prices stable. So the monetary equation of exchange is useful to think about, right, the role of monetary policy in achieving these goals. So here it is written real big: M times V equals P times Q. So economic data shows that a sustainable rate of growth for real GDP for the United States that is consistent with price stability is about 2.5% per year. Right? The United States is a very mature economy. It's been industrialized for a long time. If we start to see a rate of growth above that, we start to see a rising inflation. So if we're looking for about 2.5% real GDP growth per year, that would be a good policy goal. As I said before, economic data also show that month to month and year over year, the velocity of money tends to be pretty stable. When you look at graphs of the velocity of money, historic graphs, you see some variability. Like Mr. Romano talked last night about the 1970s and what was going on in terms of stagflation. You do see that there are times when the velocity of money is a little bit more volatile, but it's fairly stable. And so we use this little symbol of a straight line across the top to indicate a constancy or stability in that variable. So here's our big question. if we want to get 2.5% growth per year, and we want to keep prices stable too, right? This doesn't mean constant prices. It means constant rate of inflation, a stable changes in prices over time. What do we do with the money supply? Well, some economists believe that in order to achieve 2.5% growth per year, you have to increase the money supply at 2.5%. The idea is that if you increase it more than that, you're just going to drive up prices. If you increase it less than that, there's not going to be enough money in the economy to facilitate the purchase of the goods and services that the economy is producing. Okay, so that's another way to think about the monetary equation of exchange. All right, now we're going to take a look at how to, one more thing. There's a few things that you should keep in mind when you're using MV equals PQ. On the AP exam, questions on this topic are designed to assess how well you understand the long-run implications of monetary policy. And in order to do that, you really need to know the difference between real GDP and nominal GDP. So changes in real GDP reflect changes in real output. In the short run, right, changes in nominal GDP can result from changes in output and or prices, right? So if real GDP in the short run, changes in nominal GDP can result from changes in output and or prices. So P can be changing and Q can be changing. P can be changing or Q can be changing, right? In the short run. In the long run, however, remember in the long run means we're producing at the limits of our productive capacity. Changes in nominal GDP can't be due to changes in Q because we don't have the resources to sustainably produce more output than we're producing at full employment levels of output. So in the long run, changes in nominal GDP are only due to changes in the price level. So when we hold the velocity of money constant, an increase in M causes only P to go up in the long run because long run equilibrium levels of output are a function, again, of the productive capacity of the economy, not the amount of money circulating in the economy. Okay? All right, so there are a small number of FRQs that include the velocity of money. Conceptually, the idea of the long run neutrality of money, you can see in a long FRQ with an ADAS model and some monetary policy. So I'm going to take you through a few multiple choice questions so you can see this topic with this skill, and then your AP practice to set you up for tomorrow's lesson is going to be an FRQ that includes the idea of the velocity of money. Okay, so what I'm going to do now is I'm going to switch over to my document camera and I'm going to take you through some strategies for answering these types of questions. I think it's good practice because we're going to get a good sense of what the skill is we're working on. And we're also going to, you may still be having tests, you may still be having quizzes. This might help you as you're in your classes right now taking some multiple choice questions. So I'm going to change what we're looking at to the document camera. And we'll go through a couple of these together, and then I'll give you a couple to do on your own. Okay, so, and I'm also noticing that I please forgive me, that should say 3A, not 3B. Okay, so here are two sample multiple choice questions. So if the economy is operating at full employment and there's a substantial increase in the money supply, the quantity of theory of money predicts. Okay, so the minute I see quantity theory of money in a question, the first thing I do is sketch out MV equals PQ. And then I also remind myself that this is nominal GDP. Okay, so there's a substantial increase in the money supply. So M is increasing. The quantity theory of money predicts. Well, what does it predict? If the velocity of money is constant, it's going to predict an increase in nominal GDP. We could go through each of these answer choices and rule them in or out, but my advice to students is always read the question, use the tool you need to answer the question, and then look for the right answer among the answer choices. Okay, so the quantity theory of money predicts an increase in which of the following? Well, we know it predicts an increase in the price level because when the economy is at full employment levels of output, Q can't change in the long run. All right. If the money stock increases, but nominal GDP remains constant, which of the following has occurred? So again, as soon as I see some of these words, I know, okay, I have to use MV equals PQ. Okay, if money increases, but nominal GDP remains constant, that means that's no change. Okay, since these have to be equal, if this is going up and this is staying the same, what has to be happening to that variable? Well, it has to be going, I'm sorry, if the money stock decreases, forgive me, if the money stock decreases, all right, if that's going down and that's staying the same, then that has to have increased, right? So use your understanding of the formula to help solve these problems. So that would be the answer to our question. Okay, so now we're gonna go through one more together that's doing skill 3A, and then I'm gonna give you one to do on your own. Oh, please forgive me. Skill 3, here it is. 5.3 and skill 3A. So now this is very similar to the one we just did. So I'm going to give you a minute to do this one on your own. Use the strategy that we just employed. Okay, I hope what you're seeing is that this concept is assessed in a pretty consistent way. We're really trying to tease out what the quantity theory of money allows us to say about how changes in the money supply affect the economy. So you're using MV equals PQ again. We're holding the velocity of money constant. An increase in the money supply will lead to a proportional increase in nominal output. Okay. All right, so when you see velocity of money on the FRQ, you should have a good sense that you need to draw in the monetary equation of exchange, think about what the quantity theory of money tells us, and use that to answer the question. Okay, so now we're going to switch to a slightly different skill. So skill 1C asks us to be able to use a formula and calculate something. So in this case, we're told the nominal output is 100,000 and the money supply is 25,000. Then what is the velocity of money? So again, you can use your formula. MV equals PQ. So nominal output we know is P times Q. And so we know that that is $100,000. If the money supply is $25,000, then $25,000 times V is going to equal 100,000. So in order to solve for V, you're going to divide both sides by 25,000. And we should end up with the velocity of money in this case is equal to 4. All right, so let's practice that skill one more time. Okay, take about 30 seconds and see if you can do this one. Okay, it's not identical to the one before, but it draws on the same concept and requires an application of the same skill. We use our formula, we're given 3 of the 4 variables, and we have to solve for the 4th. So in this case, real output is 20,000. Well, that's Q, right? Real output is Q, and the price level is 3, and the velocity of money is 6. Then we're solving for the money supply. So 3 times 20,000 equals 60,000. Okay, so 6 times M equals 60,000. So in this case, M is going to equal 10,000. So hopefully A was the answer choice you selected. All right, so that's the way you're going to see this topic assessed regularly, and practicing that skill should be able to help you when you encounter it, if you encounter it on the free response question. All right, so now I'm going to switch back to our PowerPoint and we will head into our summary and conclusion. Okay, so we did these questions. All right, so Topic 5.3 again is money growth and inflation. And it's in this unit that really takes a look at extending our understanding of monetary and fiscal policy. The enduring understanding, the hope is that you come away from this unit really understanding that in addition to whatever short run considerations we've already learned about, there are important long run implications of both monetary and fiscal policy. So starting on Monday, when Mr. Romano is back with you, he's going to start talking about the long run implications of fiscal policy. So again, the primary learning objective was to be able to explain how inflation is a monetary phenomenon. And we did that using the ADAS model to show why expansionary monetary policy applied to an economy in full employment levels of output is going to lead to nothing except higher price levels. We looked at the quantity theory of money, and I showed you how to calculate the money supply velocity, price level, and real output using the quantity theory of money. In an FRQ, you're very likely going to have to explain how some outcome results from some cause. So you'd be given the cause, and then you'd have to explain the outcome. And these are the essential knowledge statements that go with this. So that was the subject of the new learning in this unit, and we built it based on a review of the Phillips curve, our understanding of inflation, and what we already know about expansionary and contractionary monetary and fiscal monetary policy. So this is what you should be able to do now. You should be able to predict and explain how monetary policy, when applied to an economy in long run equilibrium, will affect output, employment, and the price level. And you should be able to use that formula MV equals PQ to predict how changes in one variable affect the others. Okay? All right, now to see if you're able to do that, I'm going to show you the FRQ. And there it is, the constant money supply. Now, based on your answer, so you're going to have to work through this whole part of the problem in order to get to assessing your sense of the quantity theory of money. So if you're watching this live, go ahead and take a picture of it so you can work on it. And if you're watching this after the fact, go ahead and pause the video and try to solve the problem. Okay, so one more thing before we finish up. The College Board has asked all of us to send out a reminder through this that we know that not all the students out there have access to the internet or a device, and that the College Board is really interested in securing for students who need them devices and access to the internet so that they'll be able to take the AP Macroeconomics exam that they've been working all year long to prepare for. So if you need something to help you take this test, if you need a mobile tool or connectivity, or if you know someone does, please reach out to the College Board, cb.org/tech. Okay, thank you so much for watching tonight, and I look forward to seeing you again next week. Thank you so much.